Now in this lecture we are going to discuss another device which was used by Henry Pitot, who was the French scientist, for finding out the velocity in a river, right. So for finding out the velocity in a river, he used this simple Pitot tube, which is basically a tube tilted in such a manner so that the one portion of the tube faces the flow and another is perpendicular to it, right. To understand the concept of the Pitot tube, we must know the meaning of static pressure, stagnation pressure, kinematic pressure, total pressure, etc. So we first try to understand these terms, right. In this figure we have a pipe. This is a pipe which is shown with the help of these sections. Fluid is flowing in this direction, right, with velocity v, if this is a ideal fluid flowing. If ideal fluid is flowing and if we make hole here, which is known as wall tap, then which pressure will be measured by this tap? If this tap is connected to some manometer, then which pressure is measured with the help of this? Since there is no velocity component in the direction of the pipe, which is in this direction, in that case this one will measure the static pressure, right. And if we want to know when this velocity is reduced to 0 at this point, what is the velocity? Velocity is 0. When velocity is retarded to 0 at some point, then at this point the pressure will be equal to stagnation pressure or total pressure. Stagnation pressure or total pressure. So what is the difference between stagnation pressure and static pressure? My dear students, in the room in which we are sitting, if we consider we have a fan here, and if this fan is not rotating, even then this room is filled with air, this air will exert pressure on this wall, or if we put some device here, this will exert some pressure. This pressure comes because of the movement of molecules, and because of this molecular movement, these molecules strikes at the wall and gets diverted. Because of this, there is a rate of change of momentum, and rate of change of momentum creates a force, and that force per unit area on a small elemental step, let's say this one area, this area, then this term is known as a pressure, which is also sometimes called thermodynamic pressure or static pressure, right. If this fan is rotating, then these molecules, they attain some velocity v. Because of that, what will happen? These molecules, because of their inherent tendency at that particular temperature, they possess some momentum. Because of that momentum exchange, they create a pressure, but when these are also moving with some velocity, then they also possess some kind of kinetic energy. Because of the kinetic energy, this kinetic energy can be converted into pressure, right. We know with the help of Bernoulli equation that P over rho g plus V square divided by 2g plus z is equal to constant. So if there is no loss, then V square divided by 2g, which is known as basically kinetic energy per unit weight or velocity head, this is known as pressure energy per unit weight or pressure head. So pressure energy can be converted into kinetic energy. Similarly, kinetic energy can be converted into pressure energy. So when these particles, this particle is moving with velocity v, then it possesses kinetic energy, and that kinetic energy can be converted into pressure. So at this point we will have both pressure due to static condition and pressure due to this velocity. When it is retarded isentropically to 0 velocity, then this tip will measure stagnation pressure, which is also called total pressure. right. So with the help of this simple example, we can distinguish what do we mean by the static pressure and what do we mean by stagnation pressure. Now in the second figure, we have a pipe in which we make a hole at the periphery of the wall at point number 1, point number 2 and point number 3. Then we measure the average static pressure with the help of some device, right.